Okay, ladies and gentlemen, so today we are going to start a new chapter. And the first topic of this new chapter is representing relations and functions. So I'm going to start sharing my whiteboard in a minute so we can go over some of the concepts and get straight to it. Okay, so as I mentioned, the topic that we are going to be discussing today is representing relations and functions. So, the first thing that I'm going to do is define, according to your textbooks, define what a relation is. And we can define a relation by, or we can say, is a mapping or pairing. A relation is a mapping or pairing of is a mapping or pairing of input values with output values. With output values. Okay. So we're going to talk about that in a minute. A relation is a mapping or pairing of input values with output values, but there's some other definitions I want to go over. The domain. And the domain, we can say the domain is a set of input values. So domain is the set of input values, and the range is the set of output values. And we can say that the range is the set of output values. Now, what is input and what is output? So we can say that the input value refers to the x coordinate. So we're thinking about numbers on a number line, and the input value represents all of the x coordinates and I just realized it wasn't typing. Sorry about that. The input value represents all of the x coordinates, and the output value represents all of the y coordinates. Now, the definition that we've seen so far says that a relation is a mapping or pairing of input values, a mapping or pairing of input values with output values. And then we have the domain, which is basically the set of input values, the range, which is the set of output values. And then I just kind of explained that input refers to all the x coordinates and output refers to all the y coordinates. So there are ways in which and this is what we're going to talk about. We're going to talk about ways in which you can represent a relation, and they can be represented in various ways. Now, one of the ways that they can be represented is as ordered pairs. So you can represent a relation as ordered pairs. And an ordered pair is literally just a pairing of an x coordinate with a y coordinate. So if I give you, for example, the ordered pair -2 and +2, and we have -2 and -2. That's another ordered pair. We have 0 and 1, 0 and 1. And we have 3 and 1. So this is one way of representing a relation, which is an ordered pair, which suggests that you're pairing x coordinates and y coordinates. The other way that we have of representing an ordered pair is a graph. And I'm actually going to use the The numbers that I have in my ordered pair here, those are the numbers that I'm going to graph with, okay? So another way is representing them with a graph. And then after this, we're going to go straight into 2 or 3 real quick examples, and this concept will be easily explained to you guys, all right? So there shouldn't be too much concern or too much worry as to what we're going to be doing. Okay, so the first ordered pair is -2 and +2. So we have -1, -2, and let me actually just use a different color for this. Let me use black. So -2 is here. +2 means I move 2 spaces up, so 1 and 2. And this is my first ordered pair, or my first point on a graph. I have -2 and -2, so -2 is here, and -2 and y means I move 2 spaces downward, so that would be -2 and -2. So my second ordered pair is here. I have 0 and +1, and 0 is my origin. +1 just means I move 1 coordinate up in y. So this would be your other ordered pair, 0 and 1. And of course, I have +3 and +1. So this would be +1, +2, +3 to the right, and +1 upward. So this would be my other ordered pair. And here's the same relation that was represented as an ordered pair, but now represented as a graph. And of course, the last thing that I am going to represent or use to represent is a mapping diagram. Now, when we work with a mapping diagram, one of the things that we always do is we put our input values in order from smallest to largest. So in our mapping diagram here, the first thing we're going to do is just put our inputs and our outputs and the numbers in order from smallest to largest. Well, the smallest number in the input column, or the X column. Remember, input is domain, which also represents X, which in an ordered pair are the first numbers. So technically this is X, this is X, this is X, and this is X. So when I put my ordered my input values, instead of writing -2 twice because it's represented twice, I simply say, well, -2 is the smallest number, followed by 0, which is the next to smallest number, and finally +3. So 0 and 3. And I'm going to do the same thing for the output value, also making sure that I have my coordinates written in order from smallest to largest. And some people, they depends on what they're asking for. They may not ask you to write it in order from smallest to largest because they assume that you're going to. Just always make sure it's written in smallest and in order from smallest to largest. So my output are my y coordinates, which are these numbers here. And if I look at these numbers, the smallest number is, again, the -2. Now, again, they just kind of decided to just write random numbers in your book. So the second number that they wrote is the 2 and the 1. And then what they did was just paired. Well, -2 is paired with +2. So there you go. -2 is also paired, -2 is paired with -2, and -2 is also paired with -2 and +2. So, okay. -2 is paired with +2, and -2 is paired with so -2 is paired with -2 here, I'm sorry. And -2 is also paired with a +2 down here because they're represented here in the ordered pair. The other one that I have is 0, which is represented with 1, or paired with 1, excuse me. And lastly, we have 3, which is also paired with 1. So what we just did here is just described ways in which we can represent ordered relations. We represented them as an ordered pair, which is what we have here, as a graph, and as a mapping diagram, okay? The mapping diagram, again, what they did here was they just kind of put the input values in order from smallest to largest. The output values, that really doesn't make much of a difference. So sometimes you might see the output values written in order from smallest to largest, or sometimes you'll just see them written the way they were written here, like -2, +2, and 1. So the output really doesn't make much of a difference. I guess that's a thing of preference, but at least the inputs, normally you see them from in ordered from smallest to largest, although again, that just kind of depends on what you're being asked for. But what I want you to understand is that basically, if the first ordered pair that I have is -2 and +2, well, I pair the -2 down with a +2. If I have another ordered pair which is -2 with -2, so I go back and I pair this -2 with this -2 here. 0, 1, which means I represent this. I pair the 0 down with a 1. And 3 and 1, which means I also pair the 3 with a 1. Okay? So mapping diagrams are nothing out of this world. We are, however, going to see another example just to make sure that everyone gets the concept. So I'm going to go ahead and clear this, and we're going to go to example 1 in your textbook. Example 1 on page 72. And example 1 on page 72 says, consider the relation given by the ordered pairs, and you have -2 and -3. You have -1 and +1. Let me write a comma here. -1 and +1. And then you have 1 and +1 and +3. Sorry, just double checking that I write the right problem down. Sorry for that. 1 and 3. And 2 and -2. Let me just double check and make sure that I wrote all of my ordered pairs correctly and that I'm not missing a number. So again, -2 and -3, -1 and +1, +1 and 3, and 2 and -2. Now the problem, example 1, is asking you to do two things. So let me just label this as example 1 just so that everyone who's watching the video knows where we're at. So example 1. Example 1. And they want to do two things. The problem is asking you to do two things. A is to identify the domain and range. And B is to represent the relation using a graph and a mapping diagram. Represent the relation using a graph, and a mapping diagram. So let's do this. Let's do this real quick. The first thing we'll do A, and we'll do it right here. A is to just tell me who is the domain and who is the range now, or which numbers are my domain and which numbers are my range. Now we said that the domains are all of the x coordinates. So the x coordinates in this case would be -2, -1, 1, 2, and 3. So those are all my domains, all of the coordinates that are in x, because if I look at my ordered pair, -2, -1, 1, 2. Oh, I just realized that I didn't add an ordered pair here. That's why you're thinking to yourself, I just realized I didn't add the 3 and the 1. So there's actually another ordered pair here, guys. Sorry for that. 3 and 1. So let's go over this again just to make sure that everyone gets it. I'm sorry. So the ordered pairs that we have are -2 and -3, -1 and +1, 1 and 3, 2 and -2, and 3 and 1. So when the book is asking you to write the domain, they refer to all the x coordinates. And if I go back to my ordered pair, well, -2, -1, +1, +2, and +3 are all of my domain. Now we're going to represent the range. Now remember that the range, equals all of the y coordinates. So we're going to look at the y coordinates. And if we look at our ranges are -3, -2, 1, -2, 1, and 3. All the y coordinates, because if I look at my y coordinates, -3, 1, or -3, excuse me, -3, -2, 1, and 3. Okay, so they're all the y coordinates. Again, -3, which is here, -2 is another y coordinate, 1, and 3. They just wrote them in order from smallest to largest. Okay, whenever you're working with domains, sometimes they'll write them from smallest to largest. Always remember that. It's not always like, it's not something where it's supposed to be, but it's not always necessarily supposed to be written in order from smallest to largest, but you'll see them written in order from smallest to largest. So just remember, the important thing to remember is that D represents all of the x coordinates, -2, -1, 1, 2, and 3. And range represents all the y coordinates, which in this case, the way your book wrote them was -3, -2, 1, and 3, having written your ranges in order from smallest to largest. Okay, so sometimes you'll see it like that in the book. Don't worry if you do. It really doesn't make much of a difference. It's just because in some books, like I've seen in some books, they'll have it written in order from smallest to largest. In other books, they will not have them written from smallest to largest. The most important thing to understand, again, is that the domain is the x coordinates, the range is the y coordinates. Now, the next thing they want us to do is they want us to represent this as a graph and as a mapping diagram. So let's go ahead and graph our coordinates first. And for that, we're going to go back to our ordered pairs, and let me use black, and I guess I'll use another color for the points. I'll use blue for the points. And if you have -2 and -3, so this would be -1, -2, and -3. So this is the first ordered pair. The second ordered pair would be -1 and +1. So -1 is here, +1 is here. And this is where you would have it. You have 1 and 3. 1 and 3 is here. And then you have 2 and -2, and 2 and -2 is down here. So again, the first order pair is -2 and -3, which is down here. The second order pair is -1 and +1, which is over here. The third ordered pair is +1 and 3. And then you have 2 and -2. And lastly, you have +3, which is here, and +1. So this would represent your graph. And then the last thing that they want us to do is represent it using a mapping diagram. So kind of like what we did a minute ago, we'll have our graphs, and remember, one side is our input and one side is our output. And here for this graph specifically, the numbers of the input and the output are represented in order from smallest to largest. Okay, so let me just graph or do this little box right here, a rectangle, and let's go to and let's look at the way that they were represented. So for my inputs, again, I have -2, -1, 1, 2, and 3. -2, -1, 1, 2, and 3. And then your output is -3, -2, 1, and 3. One and three. So here we just kind of pair them up. So -2 is paired with -3. So let me actually fix this right here. -2 is paired with -3. So that would be here. And -1 is paired with +1. So that would be here. And then 1 is paired with 3, with +3 right here. And then we have 2 and -2. So that would be here. And finally, we have 3 paired with +1. And that's how you would do the first example. That's how you would represent them, as a mapping diagram and as a graph, guys. So with that, we are going to go on to our next example. Okay. So real quick, recapping. This is what we got, the ordered pair. Okay. -2 and -3, 1 and or -1 and 1, 1 and 3, 2 and -2, and +3 and 1. And they want us to identify the domain and the range. So the domains are all of the x coordinates, and that would be -2, -1, 1, 2, and 3. And our range, which would be -3, -2, 1, and 3. And that would be A. Just tell me which is the domain, which is the range, which is just domain is the x coordinates again, range is the y coordinates. B is just to represent them as a graph and as a mapping diagram. So again, I just plot the points on a graph. Okay. So if the first one is 2 and -3, this is where, -2 and -3, this is where -2 is. And I move 3 spaces down, that's where my -3 is. I have 1 and +1, so that would be, or -1 and +1, which would be my next coordinate. So -1 is here, +1, I just move 1 space up. Then after that, I have 1 and 3, so 1 right here, +1 to the right, and 3 spaces up. Next, I have 2 and -2, so 2 is here, I move 2 spaces down, that would be -2. And finally, +3 and +1. And that is how you represent it as a graph, as a mapping diagram. Input, output. I write down my domain, which is -2, -1, 1, 2, and 3. I write down my output, which is also my range, which is -3, -2, 1, and 3. And I just pair them up. Again, -2 is paired with -3. -1 is paired with +1. +1 is paired with +3. +2 is paired with -2, and +3 is paired with 1. So now let me go ahead and erase this and go on to the second example. And before I go on to the second example, there is a definition, and it talks to us about a function. So a function is just a type of relation, and a function can be defined as a function can be defined as a relation for which each input has exactly one output value. Each input has exactly one output value. So one input has one value. So let's look at example number 2. Example number 2, we have two mapping diagrams. Now let's ignore whether the fact that the numbers are in order or not, because again, that will just vary. Let's just focus on the fact of whether they are or are not function relations, okay? So if I look at example 2a, the input, the numbers that are given to me are -3, -1, 2, and 4, -3, -1, 2, and 4. And our outputs are 2, 3, and -4. So again, don't worry if you say, well, wait, why aren't they in order? Don't worry about that. It's just to represent a point. That's the way your book does it. So relax. Okay. That's the important thing is that you understand what I'm about to explain now. So you have 2, you have 3, and you have -4. So the first one says negative, and -3 is paired with +2. Let me just, here we go. Let me write that this is the output. So -3 is paired with 2. -1 is paired with +3. 2 is paired with 4. 2 is paired with 4. Or 2 is paired with -4. And 4 is also paired with -4. Now, to understand if this is a function relation or not, we have to go to the definition. It says a function can be defined as a relation for which each input has exactly one output. So the key thing here is this part. Each input, that means every x coordinate has exactly one y coordinate, or each input has exactly one output value. That means that x cannot be paired with two y's in order for it to be a function relation. That doesn't necessarily mean that it is not a relation. That just means it's not a function relation. So if I look at -3 is paired with 2, -1 is paired with +3, 2 is paired with -4, and so is +4 paired with -4. But this is a relation because if you notice, even though 2 and 4 are paired with -4, they're different numbers. Had 2 been paired with a -4 and another number, that would have been different. But 2 and +4, even though they're paired with -4, they're different numbers. So this one, we would say, is a function because every input has exactly one output. Okay? Every input has exactly one output. Every x coordinate is paired with exactly one y coordinate. Now let me erase this, or actually I believe I have space here. So let's look at B. Example 2b, you have another mapping diagram with a different set of numbers. So this is A. Let me just kind of label it. This is A, the one that we just did. And this is example 2. Example 2. And this is what we're doing now is B, okay? So this is example 2b. So the input value for this one is -2, 1, and 4. So -2, 1, and 4. This is the input. The output and the output has -4, -1, 2, and 3. -4, -1, positive 2 and 3. Okay, so we have negative 2 paired with negative 4. We have 1 paired with negative 1. But 1 is also paired with positive 2. So right here, and then of course 4 is paired with 3. So right off the bat here, I know that this is not a function because the 1, let me use a different color for it. The 1 right here is paired with negative 1 and is paired with positive 2. So because it's paired with negative 1 and positive 2, automatically this is not a function because, again, the definition says that each input has exactly one output. And here, 1, which is an input value, has 2 output values. So this one is not a function, okay? The first one, 2a, was a function because each input had exactly one output value, whereas if you look at 2b, the 1 is paired with negative 1 and is paired with positive 2. And think of it in terms of this. One person cannot be in two places at once. One person cannot be in two places at once. Because one person cannot be in two places at once, well, one input value cannot have two output values. Okay, so 2a is a function, 2b is not. Let's look real quick at example number 3, which is on page 74 of your textbook, and that will be the end of this video lesson. So example number 3, which is on page 74 of your textbooks, is a story problem. And we have two, but before we get into that, I want to explain something to you guys. Now, so far, we know that in an ordered pair, well, or we know that a function relation for each input has to have exactly one output. And we've seen that in mapping diagrams, but how will we see that in a graph? Well, in a graph, we would do what is known as the vertical line test. Now, let's say I have this function here, and we're going to talk a little bit about these kind of functions later on during the course, but let's say we have this graph. And I want to know if this graph is in fact a function or not. So what I would do in this case is I would perform a vertical line test. And a vertical line test means I literally draw vertical lines all throughout the graph. And if the vertical lines intersect the graph at exactly one point, that means that this is a function. But what if I have a graph, but the orientation or the position of the graph is different? Let's say now I have this graph. Let's say I have this graph. And I want to know if it's a function or not. So again, I have to perform the vertical line test. Whenever you want to know if a graph is a function or not, you have to perform the vertical line test. Now, if I look at this graph here, automatically I know that this is not a graph, because in this line here, it intersects the graph at two different points, right here and right down here. So automatically that would not be a function. Now let's look at example number 3 in your textbook, which has to do with a graph. And I'm going to read it to you guys on page 74, Example number 3 on page 74. It says, the first graph below plots average points per game versus age 21, versus age 21, The first graph below plots average points per game versus age at the end of the 2003-2004 NBA regular season for the 8 members of the Minnesota Timberwolves, with the highest averages. The second graph plots average points per game versus age for one team member, Kevin Garnett, over his first 9 seasons. Are the relations shown in the graph functions? Okay, so we have a graph. We have two graphs, and they're plotting. They're plotting the points that a basketball player scored at the end of a regular season versus their age. So, and I know I did this one kind of quick in class, but here I have a little bit of extra time. So the x coordinate of the graph, or the inputs values, represent the age. So we'll have age down here. And the average ages go from 0 to 34. So 0 would be here, and of course that's the origin. And you have 26, 28, 30, 32, 28, 30, and 32, and 34. So, and the y coordinate of the graph actually represents the average points, and they go from 0 to 30. So this would be about here 10. And this would be 20. And this would be 30. And these are the points. So I'm just going to say points. Points per game. I'm going to abbreviate that. Points per game. PPG. Points per game. Now, let's look at the way the graph is kind of illustrated. If I look at the graph, I'm going to see if I can use blue to represent the points better. Between 26 and 28, more or less, there's about here a point. And then again, at 28, there is one about here. And the other one is close to 30. So let's say about here, more or less. Then there's another one here. And between 30 and 32, there's another one here. And 32 will be about here. And lastly, this one goes down here. So this one goes about here, more or less. And the last one goes about here. So I want to know if there's a function relation here. And then let's look at the other graph. Before I answer the problem, let's just look at the other graph, because that way I have it graphed and it's easier to compare. The other graph has to do with Kevin is actually trying, or is representing, the points per game and the age of Kevin Garnett. Okay, so let me redraw this. Okay, so 20, again, we'll have, let's say we have 10. And it's the same thing. It's just that the second graph represents Kevin Garnett's scores and the first graph just represents players in general. So 20. And 30, which would be the last one here. So, and of course, the averages or the age in this case goes from 20 to 28. So, give me 1 second. 20, 22, 24, 26, and 28, which would be about here. Okay, so this is what more or less the okay, so the first one is going to be 20, which is about here. And this one goes about here. You have here. Then it kind of goes down a bit. It's not exactly the way it's drawn in your book, but just so you guys have a little bit of an idea of what's going on. And so the problem wants us to know if this is a relation or not, if this is a function relation or not, because it is a relation because I'm pairing. Of course, this is Kevin Garnett's age. This is the points per game. So again, P, G. And this one is for Kevin Garnett, who I'm just going to abbreviate as KG. Okay, so KG. Okay, so if I want to know if there's a function, I just draw vertical lines. And I look at the first graph, which is the points per game of every player in the Timberwolves in the 2003-2004 season based on their age. And I'm noticing right off the bat, I know that the first graph is not a function just by performing the vertical line test. And the reason is because when I performed a vertical line test, I realized that the graph actually intersects, or the vertical line intersects this graph at 2 points. So the first relation, the first graph is not a function. If I look at the second one and I performed a vertical line test, I realize that each line intersects at one particular coordinate. See? At one particular coordinate. It only, when I draw the vertical lines, it only goes through 1 point. Okay, that's basically what I'm trying to say. If I have a graph and I do the vertical line test and I notice that the vertical lines uh, go through only one exact point throughout the entire graph, that means that this is a function. If I have two, or if I draw vertical lines and I see that the vertical line crosses, or one line crosses 2 points in the graph, this is automatically not a function. And right here, this is what the fact that this is happening right here is what makes this graph not a function. So this first graph is not a function. Is it a function relation? No. Why? Again, because when I perform the vertical line test, or when the vertical line test is performed, it actually intersects two different points on the graph. The same vertical line, it's not a function because the same vertical line intersects 2 points on the line. This one, if I look at the one that is comparing Kevin Garnett's age, this one is in fact a function because each line only intersects the graph at 1 point. Notice each vertical line intersects the graph at exactly 1 point. So this is why this first graph is not a function, again, because when I perform the vertical line test, it actually intersects 2 coordinates or 2 points. And the second one is a function because it actually just crosses 1 point. So guys, that's it for this video lesson. Hopefully this video will help you understand this a little bit better. If you have any questions, you know where to find me, and I'll see you guys in our next class. Bye.